Effectiveness of various thermopneumatic artificial muscles and their fabrication methods. Pneumatic artificial muscles require external pressure systems, usually in the form of air compressors. For applications using small-scale, untethered soft robots, a simpler control system is needed. Here we see a diagram for a bending pneumatic actuator. This type is considered tethered because it uses a hose to connect the external compressor. A bending actuator was chosen to be fabricated because its motion allows for easier implementation into soft robots. PAMs are inherently compliant, making less precise actions a viable movement strategy while compared to traditional active compliant systems. However, PAMs, especially untethered ones, still cannot compete with the strength a traditional electric motor can produce. Kapton heaters were used in a bending PAM. This heater consists of a nickel-based resistive foil taped together on both sides by polyamide or Kapton tape. While it has higher heating efficiency than a TEG, it does not have the ability to cool. Ammonium hydroxide solubility is inversely proportional to its temperature. This solution was heated inside a silicone chamber. Flat PAMs were used to test how the ammonium hydroxide responded to differing temperatures because they are easier to fabricate than bending PAMs. For the bending PAM, a 3D printable mold was designed in Fusion 360. First, a layer of silicone was poured over the bottom mold. Next, a piece of paper was placed on top of the silicone. Then a Kapton heater was placed on top of the paper and its wires were taped down to prevent it from moving when curring. More silicone was poured and a flat sheet of rigid plastic was placed on top of the mold and clamped down to prevent the wires from sticking out too much. The silicone was then allowed to cure. Note that cotton fabric was used in a later design to reduce the effects of moisture on the paper. For the top section of the bending PAM, silicone was poured to 1 mm of the lip of the mold. Then the top half of the mold was friction fit in place. Once the silicone was cured, the top half could be removed, and both sections of the PAM could be joined together with another layer of silicone. As TEGs are limited in their applications, there have been few needs to promote the development of a flexible TEG. However, if such a TEG was mass-produced, a bending actuator could be constructed where one side extends while the other contracts, reducing the time of an actuation cycle. Crawler robots could also be developed, and because of their compliance offered by the silicone, these robots could be dropped from orbit on Mars, for example, with minimal landing gear and still be able to operate on the surface. Thank you.